can we rehabilitate this with minimal cost and have a service life of an extra 50 years, or is it not worth it? We need to do a complete replacement because the rehabilitation will cost almost as much as the replacement. They leave that open-ended, and it's up to the engineer to walk the client through that. So the engineer would do an analysis. They'll collect all the inspection data. They'll determine, okay, for a 50-year design life, we need to maybe replace the superstructure only, replace the bearings, the columns need to be patched because they're spalling in the concrete, X, Y, Z. And they'll give a cost associated with that. At the same time, this is all preliminary design, or like conceptual feasibility level design. At the same time,
well, we got a guy tailgating me right now.
Efficient, that's how they designed back then. Less sand, lighter material, less foundation. But anyway,
and he's so close I can't see his license plate, and he won't get off my tail. He's been doing it for about the past 20 minutes.
And we present that to the client. We do give a recommended, but at the end of the day, it is the client's choice. Based on the budget that they have, their discretion to decide one of the places to bring it. For rehabilitated bridges, a lot of times the foundations are reused. They're either reused completely without any retrofit, without any strengthening, reused with strengthened if needed. But evaluating these existing foundations is a real challenge. The issue is having limited information about them. A lot of these bridges are over 75 years old, and that's typically all the bridges are designed for 75 years design life. So those bridges that need to be rehabbed or replaced are typically at that age. And they didn't do a good job back then to record or keep and document all the, whether it's the as-built information or just the design information itself. It's either lost in translation over the years, they just don't have the information. So a lot of times we're dealing with what they call unknown foundations, which is a real challenge. At a minimum, we'd like to know the pile configuration, what type of pile. I found we do get that a lot. If we're lucky, we'll have a note in the plans giving us the allowable capacity of the pile, so we can work with that. But sometimes we don't have any of that. Sometimes there's a pile cap here, we know it's here because we can see it by observation. So to investigate those, there's a lot of means. So during that phase, we can do a lot of field tests or field studies, excavation to expose the pile, to determine what type of pile, estimate maybe how many piles. We can also do geophysical testing, done in the past to estimate the pile tip. It's done within the borehole. It's called parallel seismic logging, and we're able to do geophysical testing to determine the pile tip. We also do borings ourselves because a lot of the borings that were done in the region are not done with standard methods. So if we have the pile tip, the pile type, we typically reverse engineer the pile capacity.
CDR4